Hello everyone, and welcome to Tech Tour Workshop 4. In this session, you will know how to modernize data protection and minimize your workload. Today we will cover the modernized data protection approach, backup as a service, and disaster recovery. Data protection is complicated. First, there are many application, platforms, and data types, and each requires its own specific method and process to protect data correctly, often requiring scripts or API interface. Then there are the different types of threats, and each of these requires a different approach to protection and recovery. For example, you wouldn't want to restore an entire system just to recover a single file or email. And when you have a major disaster, such as a fire or earthquake, you'll want to recover the data from or at another location. Besides different applications, there are also different operating systems, so you'll need specialized agents and processes for each. The same with different locations: data centers, DR sites, regional headquarters, remote and branch offices, home offices, each with different levels of requirements, and different levels of local IT skills are available. Of course, not all data is created equal, and to address this, we have a number of different service level objectives. These SLOs are defined to meet the sometimes contradictory needs of the business. The first SLO is the backup window. This defines how long you can take to perform the backup operation, whether it's to protect against a file loss, a system failure, or a site outage. These may be different policies, and often are. Next is the recovery point objective, or RPO. This defines how often the data is protected. A nightly backup defines an RPO of 24 hours. This also means that you are leaving up to 24 hours of your newest data at risk between backup jobs. That might not be acceptable for more important or critical applications and data. Recovery time objective, or RTO, defines how fast the recovery should be accomplished when something goes wrong. For example, short RTO would point you to storing the backup copy locally on disk so you can restore it fast. Finally, there's always the budget limitation. Applying the best protection techniques across all of your data may be prohibitively expensive. Apply the best and fastest to only your most critical data and use less expensive techniques for less important data. All of these many combinations of infrastructure, threats, and SLOs lead to a number of different technologies to meet these needs. No single technology or solution works best for everything, but HDS is striving toward that goal. The most prevalent form of data protection is backup, either full or incremental, or a combination of both. Backup is fine for low-level SLOs, relatively long backup windows, 24-hour RPOs, and RTOs measured in hours or days. Backup doesn't work well, or at all, for more critical data. Continuous data protection, or CDP, captures every change as it is written to the disk, and therefore avoids the need for a backup window. It also provides an RPO of near zero, but it consumes a lot of backup disk storage space since it captures every change that is written, as compared to the point-in-time differences found in other models. CDP is appropriate for your most critical data, but probably in combination with either periodic snapshots or backup to reduce the CDP storage footprint. Snapshot technologies are a modern way of capturing changed data in a fast, frequent, and efficient manner. They store the data locally on the same storage array as the primary data, so they aren't suitable to protect against system and site failures on their own, but they do eliminate the backup window and enable more frequent RPOs and much faster RTOs for operational recovery. Replication, also known as mirroring, sends a copy of the data to another location for recovery following a disaster. There are several forms of replication, including storage-based mechanisms that are synchronous, metro distances, and asynchronous, global distances, as well as replication of the backup repository within most backup software applications. An effective way to improve overall IT costs and performance is to move inactive data from production systems to an archive tier of storage. This movement should be policy-based, selecting files by their creation date, last access or modification date, application and data type, owner, or other factors. Cloud storage is also becoming a popular, though potentially risky target for backup and archive data. Cloud services provide a monthly pay-as-you-grow subscription model which can be very appealing in some situations. Security, resiliency, reliability, and long-term viability are all things to consider when choosing a public cloud provider. Overall, you can see that a fairly typical environment can require hundreds or even thousands of policies that drive a number of protection, retention, and recovery tools. One way to simplify this discussion is to break the data into three classes of importance, such as critical, important, and standard data. Critical data, the things that drive the business and make you special, need to be protected from any loss or outage. These can be your e-commerce website, order processing, and CRM systems. These can also be large database systems because they can be critical and protecting them is nearly impossible with traditional backup. We need to back it up fast and as often as possible, backup window and RPO, and recover as fast as possible, RTO. Ideally, you would love to drive these SLOs to zero. Important data are things that are in process at a corporate level, like sales and marketing programs, human resources information, manufacturing, and inventory information. They aren't absolutely critical to the survival of the organization, but losing them would have a serious impact. Traditional backup and restore processes have served you well here, but they need to be faster in order to deal with the data growth you're experiencing. We need to ensure that the recovery capabilities meet the RTO, which is measured in hours and not in days or weeks. Standard data are the typical files used in our daily work: spreadsheets, presentations, documents, etc. If you were to lose all that data, it might be very impactful to your individual productivity, but in the scope of the entire organization, it probably wouldn't be a devastating loss. Traditional, scheduled, full, and incremental backups normally work well here. You just need a reliable backup for these data so that you will be able to restore them over time when needed. RTO of days to weeks is still acceptable for standard data. Unfortunately, most companies are only using traditional backup approaches to protect all their applications. As you can imagine, a majority of a company's data is standard and important, while the critical data is normally less than 20% of all the data being protected. The data protection investment spent on protecting the most critical data is far less than that on the less critical data, which makes it harder to meet the stringent service level requirements from the business. A modernized backup approach is able to deliver business-defined data protection for your company with proper service levels. In this approach, we will employ different backup technologies to protect the three different types of data. The backup technologies used to protect critical data will be much more advanced and hence able to deliver the most stringent RPO and RTO requirements. Logically, the investment spent on protecting mission-critical data from per gigabyte perspective should be higher than others. Likewise, technologies used to protect the important data will be able to deliver intermediate RPO and RTO service levels. The investment spent on protecting important data from per gigabyte perspective should be in between the critical and standard ones. To better describe the value propositions of a modernized data protection approach, the corresponding technologies are defined here. As you can see, there are different technologies catering to different business priorities. Therefore, choosing the right approach is extremely critical. For critical applications, storage snapshot protection can help customers protect data in the SAN storage by storing a point-in-time copy of the storage volume at periodic time intervals, and these copies can be reverted back for operational recovery at any time. Active-active storage solution can help customers host mission-critical data in a dual-active data center in which both storages are in true active operating mode for read-write and data is synchronized across both storages. Storage replication can help customers protect data in the SAN storage and have their data replicated to a secondary storage at off-site. Data replication can be in either synchronized or async modes. Hot standby DR solution can help customers quickly resume standby instances of their mission-critical applications at a DR site by leveraging instant recovery technologies that fully integrate with the customer's backup solution. DRaaS with Cloud provides SLA-based management DR service to customers by protecting the mission-critical applications into the cloud and providing managed DR activation for such workloads as DR instances in the cloud. DRaaS with Cloud can help a customer achieve and enhance the company's business continuity plan with well-defined RPO and RTO service attributes. For important applications, a modernized backup solution, aka hybrid backup solution, can help customers deliver better RPO and RTO values by enhancing or replacing the traditional way of backup to tape approach. Instead, important data will be backed up and stored both locally within backup storage or customer premises and into the cloud. With hybrid backup solution, the short-term retention backup copies, i.e. daily backup copies, are localized copies and always available for data recovery at LAN speed performance, while the mid- and long-term retention backup copies, i.e. monthly and yearly backup copies, are off-site copies and also available for restore through the WAN or internet when completed. This approach enhances the overall RTO compared with the traditional tape-based backup approach by eliminating the time for transporting tapes from off-site and also eliminates much of the data restore issues due to physical wear of the tapes. Moreover, this solution approach reduces the on-premises backup infrastructure footprint and can offer pay-per-use cloud backup consumption model to the customers from commercial perspective. The hybrid backup solution can further be extended to cloud standby DR solution. The offsite backup copies can be turned into DR instances by restoring them to the service provider DR cloud infrastructure. For standard applications, since the majority of the company's data normally fall into this category, an effective data protection approach, such as archive first, backup less, should be considered. The generic data types to be protected are Office documents, emails, testing and development virtual machines, business-related media files. Traditional backup approach to protecting these data can take up a lot of backup infrastructure resources, including backup capacity licenses, backup storage capacity, backup processing time, etc. By adopting an integrated backup and archiving solution, the data will be both backed up and archived to the same data management platform through data lifecycle management policies. Archived data will no longer be required for backup again, thus reducing much of the backup resources compared to the traditional backup method. Let's take a look at the first case study. Like most businesses, a global logistics company has its mission-critical Oracle database running on a SAN storage. It has implemented a data protection policy to ensure its critical data is secured. However, there are some hiccups within this protection strategy, namely, Oracle database's size is 5 terabytes and growing, but allocated daily full backup window is less than 4 hours. Needless to say, daily backup jobs are unable to complete within the window and continue into operating time. When this happens, the entire production system performance is impacted due to resources being utilized by the backup job. Daily backup means only one recovery point per day, and this poses a big issue as data loss can be up to 1 day. Being a mission-critical system, the data in their Oracle has to be recovered with minimal or zero data loss, otherwise it would mean huge losses to the business. The business realized that these challenges mean they need to revamp their data protection strategy and has set new expectations to protect their critical data. Backup jobs must be completed within the allocated backup window and must not impact production server performance. RPO needs to be improved to the measurement of seconds to minutes, a huge enhancement from their current 1-day recovery point. The trend now is to employ a modernized backup solution that is specifically designed to protect critical enterprise applications such as Oracle, SAP, DB2, Microsoft SQL, Exchange on physical and virtualization platforms on SAN storage infrastructure. Take the Oracle database backup use case as an example. A modernized backup solution can address the challenges by delivering the following capabilities. Application-aware backup. The backup agent software installed on the Oracle server communicates with Oracle application in order to tell the application to move the data from memory to the disk prior to informing the storage to take a hardware snapshot. This ensures that each point-in-time snapshot being taken will be at application consistently level. Integrates with storage snapshots. The backup solution is fully integrated with the SAN storage, and through such integration, creating a backup policy for Oracle database is simplified as the calling of the storage subsystem through API or CLI method for orchestrating the storage snapshots are fully automated. Backup administrator is only required to manage and operate backup and restore jobs at the database application level. Simplified database cloning. By leveraging snapshot backup protection, Oracle databases can also be cloned for testing and development or non-production use. Instant recovery by reverting snapshots for production use. Now backup administrators can easily select a point-in-time snapshot copy from the backup management console and revert it for production use. As the whole process is seamlessly integrated with the underlying back-end storage, the storage snapshot revert processing time normally takes between seconds and minutes. This greatly improves the RTO for the Oracle application. Mount snapshot images for off-host backup processing. Backup administrators can schedule the backup server to perform backup for the specific point-in-time snapshot off the storage to backup storage or tape for DR purpose. The point-in-time snapshot image will be mounted to the backup server for the off-host backup processing. This ensures that the backup process will not consume any computer or I/O storage resources of the Oracle production server. Index snapshot copies for granular recovery. Once the point-in-time snapshot is presented to the backup server will index the data in the snapshot and make the Oracle data available for granular recovery. By combining the storage and database layers into a backup solution, customers will realize a number of benefits from operational perspective. Storage array leverage. Large databases are quickly protected. Low to zero protection I/O impact, clone, equals no I/O impact, while snaps equals minor I/O impact. Fast accessibility. Mount and browse or automate snap recovery through the standard browse and recover process. Multi-streaming for data movement. Mixed mode protection. Database logs may be protected more frequently than the entire database for log manipulation to exact PIT database storages within the point-in-time storage snapshots. Seamless recovery from multiple storage tiers. Automatic sequencing of log files and database files for direct point-in-time recoveries across storage tiers. Faster recovery mechanism leveraged by default. SAN copies are utilized for LAN-free recoveries first. This second case study looks at protection of important application data. These consist of traditional files, emails, and web server data that are deemed important enough to have serious impact to the business if lost. The challenge faced by the customer in this situation is that protecting this data requires substantial amount of resources. Backup is performed daily to tapes and sent off-site to DR. These tapes are then stored off-site for retention based on the policy daily 31 days, monthly 12 months, and yearly 7 years. As you can see, the company needs to maintain a huge amount of tape inventory and at the same time ensure these tapes are well preserved to prevent data corruption. The infrastructure supporting it, i.e. the tape library, human resource, vaulting has to be done in working order for as long as the tapes are being kept. This translates to significant effort and cost. Restoring from tapes located off-site also proves to be a hassle, as the correct tape needs to be located among a huge inventory of tapes and then physically sent back to the production data center for restoration. All this consumes a significant amount of time, and not to mention that after all this is done, there is the possibility of failed restoration due to tape media problems. With these issues affecting the company, they are looking at ways to improve RTO from a few days to within a day, or preferably better. With the issue of tape media having issues like corruption, the company is looking at solutions to improve restoration success rates and a more efficient way to manage mid- and long-term backup data without compromising SLAs. For companies with a single data center, their production and test and development server farms are all in that single location. Generally, these companies tend to use the traditional backup approach to protect their corporate applications and data. Their backup approach tends to lack the following features which a modernized backup solution will provide. Resilient backup. They normally only keep a single backup copy of their data in the tapes, which are kept off-site. Any problems with the tapes may render them unable to perform data restore when needed. Tapeless backup. They are either doing backup to tape or backup to disk to tape, and their tapes will get set off-site for DR restoration purpose. They are unable to eliminate tape backup infrastructure due to the fact that they don't have a secondary data center for replicating their backup. RTO enhancement. Due to the fact that off-site tapes need to be sent back to production data center every time when needed, data restoration process usually takes days instead of hours or minutes. Reducing on-premise backup footprint. The more data requiring backup protection, the more backup storage and tapes are needed for traditional backup approach. Furthermore, more tape storage vault is needed for storing the increasing number of tape media. Consumption model. With a traditional backup approach, companies tend to purchase and build the entire backup infrastructure on-premise, including the backup servers, backup storage appliances, tape libraries, backup tapes, and backup software licenses. Sometimes the backup infrastructure may be over or under provisioned, a normal behavior of CAPEX model, which can hardly be avoided. Backup infrastructure SLA. We have seen in large variants for different customers requiring this as a traditional backup infrastructure can be managed by customers themselves or by external outsourced parties. This is quite different from the cloud backup service SLA, which many service providers offer today. For instance, HDS Cloud Services Connection offers up to 99.95% uptime SLA for its online backup service as a guarantee to the customer, which greatly improves backup operational efficiency. These companies can achieve the benefits by transforming the traditional backup approach to a modernized hybrid backup approach. Based on our field experience and feedback from many customers, they are telling us that backup data older than 1 month would need to be restored only occasionally or for IT audit, DR, or DR drill purposes. Thus, keeping all the backup retention copies on customer premises may not make a lot of sense to many companies. With cloud backup getting popular these days, it makes sense to keep the mid-monthly backup and long-term yearly backup retention copies into the cloud, while the short-term daily backup retention copies are kept locally on customer premises. Optionally, customers would like to keep a secondary off-site copy for their daily backup into the cloud for DR considerations. In case something bad happens to their production environment, their recent off-site backup copies can be restored as cloud servers in the service provider cloud when needed. HDS Online Backup Service is an example of a solution capable of providing such a feature. For companies having 2 independent data centers, their production and DR server farms are either hosted in active standby or active-active DC. For companies with active standby DC, they normally have a backup infrastructure deployed within the production DC for backing up their production applications and data to tape. Periodically, the backup tapes are sent off-site to the standby DC for DR purpose. The companies with active-active DC normally have a backup infrastructure deployed within both DCs for backing up their production applications and data at each site to tapes. Periodically, the backup tapes are sent off-site to the peer DC for DR purpose. By considering modernized hybrid backup approach, these companies are able to achieve the following economic advantages. They can reduce on-premise backup footprint by backing up to the mid to long-term backup copies to the cloud, that is, the monthly and yearly full backup instead of tapes. The reliance of backup tapes and its corresponding infrastructure is eliminated here. They can eliminate tape vaulting and management cost as both tape infrastructure and tapes are removed. Improve RTO as backup copies are always online and available to restore locally or from the cloud, which is not possible with the traditional tape-based backup approach. Achieve better capacity planning for backup infrastructure as the hybrid backup approach effectively avoids over-provisioning of backup resources while reducing costs with cloud backup consumption model. This is a reference architecture of a modernized hybrid backup solution. At the customer DC, daily backup is performed locally with retention up to 31 days for quick restore. As we discussed earlier, it is important that new and daily backup data be kept available locally on-premise to ensure RTO is kept to near zero. The same daily backup data is replicated to an off-site backup infrastructure hosted on the Hitachi Cloud Services connection. At this location, the short daily, mid-monthly, and long yearly term retention copies are kept with a 99.95% uptime SLA. To complete the data protection requirements, the solution can be extended to include a cloud-hosted DR infrastructure. Off-site backup copies are restored to the DR cloud infrastructure, and this will turn into DR instances without the need for additional replication or backup. As you can see, the modernized hybrid backup solution gives you a complete end-to-end data protection solution while addressing the typical challenges faced by traditional backup solutions. Common use cases for standard applications are PC and laptop user data, file servers, testing and development systems, and UAT systems. This is the data that we use daily in our jobs, and as we are all aware, we create and read, write, modify these documents at least once a day, usually a lot more than that. So imagine how much data is generated by standard applications. Indeed, standard data is growing at rocket speeds. Using traditional daily backup approaches are no longer an efficient way of protecting data, as this will consume much of the backup resources: backup servers, storage, tapes, backup licenses, backup windows, backup bandwidth, etc. While considering backing up data on a daily basis, why not consider archiving it in the first place? From a modernized data protection perspective, backup and archive of data leverage a unified data management platform, meaning that companies do not need to build and manage two separate platforms in the environment. The archive more, backup less approach can be achieved using an integrated backup and archive solution incorporating the traditional backup and archiving processes in a single operation instead of conducting this process 3 times. It is aimed at organizations who must protect and retain large files and large amounts of data because the scanning processes in these scenarios can be lengthy. The data from backup clients gets backed up only once as part of the backup operation, and the files that meet the archiving rules are stubbed in place. Stubs point to the data that was already moved as part of the backup. The integrated agent is able to selectively age items based on data and stubs that are deleted on the primary source. This allows you to reclaim space in your secondary storage. It also provides data statistics and reporting functions. Additionally, this agent also allows backup data statistics and analysis reporting functions without having to revisit the primary storage again. As a result, organizations can realize the following benefits. They reduce the combined time typically required to backup, archive, and report. It reduces the impact to production environments and server performance. It eliminates redundant storage at the source. It enables streamlined legal discovery and review for data files. It manages costs and capacity while reaching performance goals. Enterprises may have options to deploy resources in a virtualized data center or cloud, but require a better way to protect this environment and create more value from the data being managed. VM sprawl results from pervasive deployment and growth of virtual machines, some of which then sit unutilized long after their useful lives. It is an increasingly common and complex issue especially in large infrastructures, for example, consuming CPU, memory, and VM storage resources, creating VM software licensing issues, impacting production VM performances, and creating unnecessary backup jobs for the VMs. Testing and development VMs are regarded as the major contributors of VM sprawl issues nowadays. Many VMs are created and duplicated without housekeeping being done, and they continue to use up resources. The ability to automatically archive underutilized VMs provides significant cost savings and efficiency and is a key strategy for enterprises on their journey to modern data management. VM archiving reclaims idle virtual host and shared storage resources by automatically managing and moving unused VMs to cost-effective storage with the ability to instantly recover archived VMs for increased utilization, efficiency, and savings. Using administrator-defined policies, VM archiving functionality can automatically identify, power down, relocate, archive, and recover inactive virtual machines in the virtual environments with the following innovations and benefits. Finds, relocates, and retires stale or orphaned VMs during the backup process to enable increased administrative control. Sets parameters for automatic management of virtual resources and expiration criteria based on CPU, network, and disk usage. Once configured, archiving is performed as part of the normal backup cycle, increases utilization, and reduces storage hardware costs by automatically moving powered-off VMs for expensive Tier 1 disks to more cost-efficient, longer retention tiers, either on disk or in the cloud. Relocated VMs can be archived at the same time or later. Streamlines testing and development operations by continually recycling compute, memory, and shared storage resources in virtual hosts. Recovers archived VMs in a single step using a stub marker at the virtual infrastructure level. While many organizations are taking steps to transform into modernized data protection approaches, not all of them have adequate skills and resources to manage the transformational process and the transformed infrastructure. Backup as a service delivers a complete end-to-end backup service to customers, from providing the backup infrastructure and backup service catalog to managing the day-to-day backup and restoration services. HDS developed this service for enterprises with stringent data protection requirements. It employs industry best practices for data protection with data backed up on-premise and remotely in the Hitachi Cloud Services Connection data centers as an option. More importantly, backup as a service customers are able to enjoy the business-defined services levels for different applications based on their business priorities, while the underlying backup technologies are handled by HDS as their managed service provider. The backup as a service includes the following. Dependent on application requirements for data protection, an organization can define the SLA from the provided service catalog. HDS understands that there will be different requirements based on the criticality of application data. Therefore, the choice of choosing the best-suited SLA gives companies the flexibility to define their data protection strategy. Consumption-based pricing model means you only pay for what you use. This is a shift away from the traditional approach of CAPEX purchase of the entire backup infrastructure and also significantly reduces operational resources and cost. 24/7 remote monitoring, administration, and management of backup and data recovery process. Rest assured that someone is always watching to ensure backup is done successfully every time and will be on hand to perform any ad hoc backup and recovery requests from users. No need for an organization's in-house IT resources to be on standby during off hours, and this results in further savings for the company. Data retention will be done on the Hitachi Cloud, therefore eliminating the need for tapes and tape infrastructure investment. Restoration will be much quicker with RTO of minutes to hours instead of days, as there is no need to locate and transport physical tapes. Full suite of infrastructure and backup management services. The entire service is based on ITIL version 3 standards, and this means consistent quality of service and the ability to quickly and professionally react to changes in business. A detailed monthly reporting on consumption and utilization on infrastructure and backup services, allowing customers to gain a clearer view of their environment and to perform optimization if required. HDS Backup as a Service is designed for the enterprise to meet their data protection challenges. Reliable data protection infrastructure. With an on-site backup infrastructure, organizations get the best of both worlds, local and off-site backups. Company data is backed up to an on-site backup vault and periodically replicated to an off-site backup vault hosted in the Hitachi Cloud Services Connection data center. This makes LAN speed backup and restore possible, ensuring RTO performance. Additionally, this solution reduces risk of data loss arising from natural disasters and site outages. Backup Service Catalog. Offered with measured SLAs for various service matrices, including RPO, RTO, backup, and restore success rates. The HCSC operation team acts on specific backup and restore operations upon service requests. Tapeless backup. Organization backup data is retained in disk-based management backup infrastructure. This modernized backup approach means backup data is always online and available for restoration at any time. Tapeless backup eliminates the need to manage physical tapes, greatly reducing operation and capital costs. Bottomless backup capacity. Consumption-based model, backup capacity on demand, and with unlimited scalability of backup. Broad platform support. Provides support for virtually every popular server, Windows, Linux, and Unix, hypervisors, database systems, and application platforms used in the enterprises nowadays. Service management and ongoing support. An enterprise-grade managed backup and recovery service for your business. Standardized service delivery and governance model. ITIL-based best practice methodology fully integrated into existing processes and tool sets. Round-the-clock, proactive backup infrastructure management, monitoring, alerting, and support. Comprehensive monthly reporting with full visibility of backup usage, service SLA, backup restore success rates, and billing detail, including chargeback. What makes our backup as a service unique? Business-aligned service catalog, data protection as how the business wants it. With varying SLAs based on requirements, gone are the days of one backup approach for all types of data. An HDS team focused purely on backup services will monitor, administer, and manage your backup, ensuring your backup and restoration activities are well managed. The HDS team will proactively engage with application owners to review their current backup and recovery process and to discuss potential optimization plans. The team focuses only on data protection, therefore they have very clear objectives, which is to help customers achieve better results. Periodic restoration tests are performed to ensure no corruption of backup data. This is to ensure that when required, restoration is done without hiccups and within the SLA. There will be daily and monthly reviews on the backup, restore performance, and utilization. Consumption, performance, and health reports are made available to customers for review and to perform chargeback if required. This is the Backup as a Service service catalog for a generic customer. Customers are offered with measured SLAs for various service matrices, including RPO, RTO, backup, and restore success rates. The HCSC operation team acts on specific backup and restore operations upon service requests. The scope of backup as a service is detailed here. Backup server and storage hardware provisioning, monthly backup usage reporting is included as part of the base backup as a service offering to customers. For more comprehensive operation and management tasks, customers can go to the Managed Services option, which extends the services to tasks like ad hoc backup and restore, performance management, managing backup policies, and job schedules. Traditional disaster recovery solutions are naturally complicated in their architectural design, which makes it difficult for organizations to implement and maintain. They also require standby hardware for fast recovery. This complexity not only creates high costs and heavy workloads in disaster recovery management and operation, but it also limits the solution's flexibility and scalability to meet ever-increasing and ever-changing threats. The high costs have also resulted in businesses selecting certain workloads to protect, while other workloads, usually deemed less important, are left unprotected. These traditional disaster recovery solutions utilize off-site data and application backup, which results in a recovery process that can take days and recovered data that is not the most up-to-date version. In today's time-sensitive business environment, that level of recovery time is simply unacceptable. In general, planning and building a successful disaster recovery solution requires 4 major steps. Step 1. Pick appropriate RPO and RTO for the business applications to be protected under your DR plan. While it is easy to categorize all applications as critical and have the same service levels applied across, it is certainly not the most effective way. Step 2. Identify the network bandwidth requirement to support your DR plan. Step 3. Prepare your DR environment in accordance with your DR plan. Step 4. Test and verify your DR environment to ensure it meets the RPO and PTO requirements for your DR plan. RPO and RTO are business decisions. Recovery Point Objective, RPO, is defined by business continuity planning. It is the maximum targeted period in which data might be lost from an IT service due to a major incident. The RPO gives system designers a limit to work on. Recovery Time Objective, RTO, is the target duration of time and a service level within which a business process must be restored after a disaster or disruption in order to avoid unacceptable consequences associated with a break in business continuity. Every mission-critical application has an RPO and RTO requirement driven by business. The best way is to talk to the business decision makers to fully understand how their business's application's SLA requirements, e.g., 0 RPO, 3 hours RPO, etc. Get your current RPO and RTO. Get business owners' agreement on RPO and RTO. While having a conversation with the business decision makers, you need to understand what their systems are capable of, how much data changes are involved for the protection systems, what are the impacts to the systems if the RPO fails, etc. Test options and estimate costs. Always test the systems and make sure the largest RPO and RTO are achievable with the proposed storage and network bandwidth requirement. Without testing, you will never know whether the DR solution will work or not. Implement and measure. Once the testing is done, you are good to implement the DR solution and measure the baseline. In order to plan and build a DR solution, network bandwidth is the key. Bandwidth in this refers to 2 states, the initial upload and the ongoing usage of the application. Initial upload refers to the initial data streaming to the off-site DR infrastructure. It is the largest bandwidth used in the DR solution implementation process. It is not time-sensitive since the initial data streaming can be scheduled at any time suitable for an organization. It is to be carried out in a phased approach. For instance, consider having 10 hosts per batch to participate in each initial upload process at a specific time that makes sense for an organization in terms of network bandwidth and operational window, etc. Ongoing usage of the data refers to the constant streaming of the data to the off-site DR infrastructure. It can be the largest continuing cost of supporting the DR solution. It can be considered most critical to your operations. Whether the ongoing data upload process is encrypted is a critical matter in providing data confidentiality of the organization's data. DR drill and failover access. It is related to the accessibility of the DR instances by the end users once DR has been activated. Network routing and connectivity should be well planned in advance prior to the DR and DR drill exercises. When planning for DR failover access, apart from the network routing and connectivity, application domain name failover mechanisms should also be well planned ahead such that application systems under DR failover state are accessible by the end users or related client systems seamlessly. Again, all these need to be planned and tested out properly. To plan the DR environment, you need to select the right tool. You need to pick the tool that is right for supporting your DR environment. For instance, DR infrastructure, for example, an ASR with HDS DR infrastructure, and network infrastructure, example, Global Server Load Balancer for domain name failover for your applications. Know DR settings. You need to define the DR plan for your protected applications and the DR runbook for operating the DR process. Configure your network. You need to define the network connectivity, e.g. Layer 2 network, network subnets, IP address schemes, DNS domain, IP routing for the DR environment that work for your organization, and create your connections. Once the network configurations are implemented, you need to create connections for linking up the production and DR environment, including but not limited to Active Directory sites, data replication for the protected servers, etc. To ensure that your IT DR plan is operating as it should be, you will need to test it on a regular basis. This includes executing the DR plan based on the DR runbook and making adjustments as needed. Your IT DR plan should be tested at least once a year. Anytime a test is performed and issues creep up, it means that your IT DR plan needs to be updated. Log all activity during an IT DR test from start to finish. Analyze the logs and fine-tune problem areas and update your existing IT DR plan to incorporate these system changes. Do keep in mind that DR testing will involve any entity working with your company, so you may need to contact vendors and suppliers ahead of time. This case study involves a customer who is looking to build a new DR environment. Currently, they do not have any DR solution implemented, and therefore all applications are not properly protected for DR. A traditional offsite backup is still used, and in case of disaster, the recovery operation is long and complex because of the use of the offsite backup copy. Realizing this, the customer is looking to build a proper DR solution, but is prohibited by the high setup and management costs. However, audit has put a lot of pressure on IT to shorten RPO and RTO and to assign data protection efforts with the business. What the company hopes to achieve with a new DR environment is the DR solution must be able to provide a clear view on the health status of DR plans, reduction of effort in setting up this new DR solution, as well as ease of ongoing management, a dedicated managed DR services team that is focused on the task. Due to corporate standard, the company wants to be able to bring its own network equipment and use its own telco provider at the DR data center. To increase RTO and RPO, as well as reduce storage footprint on production data center, sending and storing remote backup copies to DR data center is required. In this case study, the customer data center has servers which are running on Hyper-V and are collectively known as protected servers in the diagram. With ASR, snapshots are taken using CDP agents installed in the protected guest OS. These applications' consistent snapshots are point-in-time snapshots taken of the application data in the protected servers. Replication of these snapshots are then performed via a secured connection to the hosted HDS DR data center. At the hosted DR data center, the replicated data can then be used in case of disaster. When failover is triggered, simply fail over to this secondary location to keep applications and workloads available. They can also be used for recovery in event of data loss. The connection from customer's office to the HDS DR data center is via a routing device, which only activates during failover. With this new hosted DR, the customer's challenges are addressed successfully with the following benefits. A ready DR infrastructure for critical servers within 6 weeks, as compared to the common practice of setting up a new DR data center, which could take months to years. With committed service levels, the customer is able to ensure that RTO and RPO meets application requirements. The IT team is now able to focus on more important projects and activities as they do not have to put as much effort into DR, infrastructure, planning, and plan management. The customer is able to direct its resources to enhancing or improving their IT environment. Let's look at another case study. Case study number 2 describes how a company has embarked on a new data center construction together with technology refresh of their existing infrastructure. This is an exercise carried out by most companies when their current technology is obsolete or they have outgrown their existing data center capacity, or both. There are several challenges faced by the customer when performing this upgrade to their data center, but the more prevalent ones are namely, their current DR facilities and tools cannot match the new data center standard. In order to match the new data center, customers will have to upgrade DR facilities, but this translates to double investment cost. Limited resources at the DR environment for operation and management tasks as IT staff are focused on the new data center setup and learning of new technology. With these challenges in mind, the company is looking for a single DR solution that can support all production applications of about 140 guest OS with different critical levels. These levels are categorized into 3 mission critical, important, and moderate, each levels having its own target RPO and RTO. The new data center has been upgraded, therefore they expect the hosted DR service to be a Tier 3+ data center to ensure a match in capabilities. To reduce operating and capital costs, the hosted DR service should be based on a consumption or pay-as-you-go charging model. Using ASR, physical and virtual machines are replicated to the Hitachi hosted DR data center via a dedicated point-to-point link. With the hosted DR AAS solution, all it takes is a single management interface to configure and monitor DR plans like bandwidth usage, RPO, etc. There is no reliance on multiple consoles, thus reducing complexity and increasing productivity. The company also benefited from offloading its DR infrastructure management and operation to a service provider and enabling their staff to focus on important projects and workloads. Overall, the organization managed to achieve a total reduction in TCO. Why HDS? HDS DR as a service is based on a validated approach backed by Microsoft Azure Site Recovery best practice. With HDS DR as a service, organizations are able to deploy an agile cloud-based DR solution on shared or dedicated infrastructure. Moreover, network connectivity to DR as a service environment is highly customizable in order to facilitate the different DR deployment scenarios for the BCP. HDS consultants and operations support staff are ITIL certified professional and follow ITIL-based operation for managing customers' hosted DR environment and HDS's Tier 3+ data center. HDS Managed Services for DR provides organizations an end-to-end BCO solution from DR solution design and DR infrastructure setup to DR drill testing and DR failover services. To summarize, the Hitachi solution bridges the gap between business and data protection and helps to define clearer service levels based on business requirements. The market is moving towards IT transformation and business-driven IT. Therefore, steps have to be taken by organizations to remain competitive. Backup as a service lets you gain control of your backup operations, while at the same time reducing costs usually associated with backup, for example, tapes, tape infrastructure, and manpower. With backup as a service, rest assured that your data protection service levels are more easily met and RPO and RTO is reduced. DR as a service is the final piece of the puzzle because in cases of disaster to the production data center, a quick and efficient approach to resume your business with as minimal downtime as possible. With cloud-hosted DR infrastructure, you can pay as you consume and do not need to worry about building your own DR data center from scratch. If you want to know more, simply email us at info.hk@hds.com. Thank you.